exists in S. So let me underline the important stuff. The least upper bound, or S has the least upper bound property. That's what we say. If every subset that has an upper bound has a least upper bound. Okay? Now using these words, what can we say about Q? Well, for instance, but specifically using these words, something about the least upper bound property. Q does not have the least upper bound property. I'm just going to put an LUB property. I'm tired of writing least upper bound. Okay? I'll even make it capital. Whoa. I'll make everything capital. Usually when you see this written in books, everything's lowercase. But just because L's look like ones, look like everything else. Alright? And literally that was the point of yesterday's lecture. That's the point, that's what we were trying to get to. We were trying to show, this is what I mean when I say Q has holes. There are sets that don't have a least upper bound. Okay? I know, boring, I'm sorry guys, but we're almost there. So let me give you one more example relating to this. So it turns out, and the kicker for today is going to be this. R does have the least upper bound property. R is an ordered field with the least upper bound property. That's going to be one of the big theorems I'm going to state today. I'm not going to prove it because, I mean, Rudin takes, I think, 4.5 pages to prove it. It took me like 6 boards to prove a 1-page proof yesterday. I'm sure you get the point. I might prove it like for culture at some point for like a gimme lecture that I'm not going to test you on, like when we need a day off. But that's a maybe. I don't even, it's not even necessarily, I mean, I recommend you read it. It's a great proof. It's just that it's like really long. So here, let's just try another one. So I'm going to tell you right now, R does have this property. And we'll talk about it in a second. But here's an example. Another example, find the supremum of E and infimum, where E is equal to this. And then we're going to actually do a problem from the worksheet again. The set of all, so this is pretending we already know what these functions are, because you do, but I'll define them again sometime, such that X is real. So I want you guys to tell me, so do you guys understand the set notation? The set is all things that look like sine of X times cosine of X for some X. You know. Find the supremum, find the infimum. So let's take again, 5 minutes, work with your neighbors. Not only should you have a good stab at what it is, you should be able to justify to me in some way or another that this is what it is. Okay? Cool. And then we'll look at, and should you be, okay, and so actually, why don't we, how am I doing on time? Okay, wow, this is going a lot slower than I thought. Wonderful. So, how about we do this? So, I'm going to give the 10-minute break now. You're welcome to go do whatever you want. You can start thinking about this problem. But we're going to take, so 10-minute break ends, it's at 11:11. Easy number to remember. Then I'm going to give you guys 15 minutes to look at this and then number 3 on the worksheet. And we're going to come back, talk about those problems. I'm going to give the main theorems for R. And then I guess we might actually not get to C till Thursday, which is fine. Or I might just hit C tomorrow in like a super lecture. So take a look at 3, look at this problem, and I want some answers for all of them. Just think it through. Some of them are just tricky, and some of them are to remind you of notation. Wonderful. Enjoy your break if you want, or feel free to work through it. It's a good idea.